Hey, what's up? It's Powell, and in this video I'm going to show you how to graph sinusoidal functions using what I like to call the box method. Now, essentially what the box method does is it creates a box in which you can graph one full period of any sine or cosine function if any of the four or all of the four transformations are applied to it. And the transformations are vertical shift, amplitude, phase shift, which is sometimes called horizontal shift, and period. Now, vertical shift and amplitude are your vertical transformations, and phase shift and period are your horizontal transformations. Now, it matters what order you go in as long as you do the shift before the accompanying transformation in the accompanying direction. So what I mean by that is you can either do it vertical shift, amplitude, then phase shift and period, or I don't want that to go, just these two. Or you could do phase shift period and then vertical shift amplitude. I prefer to do it in this order, but you may prefer to do it in the other order. But you have to do the shift before you do the other transformation that goes along with it. For this example, we're going to use f of x equals 3 sine of 2x plus pi minus 1. And before you can do any graph of sine or cosine, at least with this method, what you need to do is factor out the coefficient that is with the x inside the sine. So we're going to change this to f of x equals 3 sine of parentheses 2 parentheses x plus, and when we factor out the 2 we get pi over 2, double parentheses to close off the sign, and then minus 1. And now we can look at all of our four transformations. Now in the order I've written them, the first transformation is, that's the wrong tool, that's the one, is vertical shift, which we're going to label D. The second one is your amplitude, which is the 3, which we're going to label A. And then your third one, phase shift, is plus pi over 2. I took the plus with it for a reason, which we're going to label C. And finally, the number that affects the period is 2, and we're going to label that B. And generally, these are labeled like that, so it's A, B, C, D, so they're easy to remember. Oftentimes C and D might be H and K, which would link up to what you may have learned with vertex form of a quadratic or absolute value functions. But for this example, I'm going to use A, B, C, and D. So I'm going to go through each of these four transformations and show you how they're graphed on the graph to make the box. Peeking over my shoulder. So the first one is the vertical shift. Now, the value D is -1, so what that is going to do is it's going to move the midline of the function down 1. So it moves midline down 1 unit. I'm just going to move my graph. And I'll talk about my graph in a minute. There's a very specific way I scale my graph for sinusoidal functions. Again, you may not want to do it that way, but you might. Now, normally the midline is at the x-axis, but in this case, it's going to move down 1. So I'm going to put a dotted line at -1. And I scaled my y-axis by 1. I didn't do anything too crazy with that. Now, the value for amplitude is 3, and what that does is it tells you how far away from the midline the maximum and minimum values are. And normally they're 1 away from the midline, but because we're multiplying the function by 3, the max and min are also multiplied by 3. So, or I should say they're 3 above and below the midline. So this represents where our maximum value is. You can see it's going to be a 2. 1, 2, 3. And this represents where our minimum value is, and that's -4. So already we have our upper and lower parts of our box and our midline. Now the next transformation is phase shift. And you'll notice on my, I never actually wrote in what the amplitude does. The max and min 3 units from midline. Now you notice the scale on the x-axis in this example, I'm going by pi over 4s. So every space is pi over 4, which means every 4 spaces is pi, every 2 spaces is pi over 2, etc. What the phase shift is going to do is it's going to show you where one period begins. So it's essentially your starting point, but because it's a periodic function, it's going to repeat going in both directions. But for one period of this sine function, this will tell you where it starts. So because we have plus pi over 2, you might remember from any function like vertex form where if you add a value in, it actually, inside the function, it actually moves it to the left. And if you subtract a value in there, it actually moves it to the right. So in this case, because we're adding pi over 2, the graph is moved pi over 2 to the left. So my starting point is going to be at negative pi over 2. So moves starting point left pi over 2. And that's why I encompass the plus pi over 2, because it will move it to the towards the negatives. Now period is a little weird because 2 is the number that affects the period. 2 is not our period. In fact, the period of any periodic function is equal to 2 pi over b. In this case, our b value is 2, so our period is 2 pi over 2, and that equals pi. The reason it's 2 pi over b is because 2 pi is the period of a regular, unaffected, untransformed sine and cosine, and the b value divides it into its new period. Now it's important to note that this is not where the function ends. This is how long the function goes before repeating another period. So the way I like to do this is I like to see that pi is 4 spaces. It represents 4 spaces. So 1, 2, 3, 4. And since pi radians is 4 spaces, I know that the period of one cycle of this sine is 4 spaces. So 1, 2, 3, 4. So it's actually going to end right here before it repeats again. So what you'll notice is we've created a box that one period of our function is going to go in. Now the last thing we have to talk about is how sine behaves. So sine, it begins, if you remember what a regular sine looks like, it begins at the midline, like regular unchanged sine begins at the x-axis. 1/4 of the way through, you reach your maximum value, which normally is 1. Halfway through, you're at your midline again. 3/4 of the way through, you're at your minimum, which normally is -1, and you always end at the midline before you cycle through again. So this represents 1/4, 1/2, and 3/4. So I know, I'm going to make the graph a little thicker in this example. I know I'm starting at my midline. 1/4 of the way through, I'm at my max. Halfway through, I'm at my midline. 3/4 of the way through, I'm at my minimum. And you end at the midline before it repeats again. And that's one full period of f of x equals 3 sine of 2x plus pi minus 1. Now this method is even cooler because if I want to do another period, and in some cases you might be asked to do 2 periods of a function, again I know that one period is 4 spaces, 1, 2, 3, 4, which represents pi radians, and I just repeat the process. 1/4, 1/2, 3/4, and you're finished. So that's the box method with sine. In my next video, I'm going to do the box method with cosine. It's pretty much the same thing, only the order of mid to max to mid to min to max is a little different. And that's really the only difference it is. In the cosine video, I might do not all 4 transformations so you can see what the defaults for some of them are. And I'll talk about that in the next video. If you like this video, please subscribe and share this with someone that you think may benefit from it. Thanks for watching.